We've got a couple of problems for you to look at.
These students are solving a series of short mathematical problems designed to develop their skills in applying mathematical knowledge in problem-solving situations. Throughout the tasks, the students are encouraged to ask questions and discuss their thinking with the teacher and each other. The first problem comprises some questions involving surds.
There were a couple of multi-stage small problems where perhaps there was some new terminology in the way of relating surds together, where there was quite a sort of an element of discovery.
When I first saw them, I had no clue where to start, to be honest. It was very hard.
First of all, you actually have to think about it and not just plug it into a calculator. That's what I felt like. A little bit different. A lot more thinking is required.
It's more like trying to figure out how to do it rather than you knowing how to and whether you can apply it.
On the first number, they've done 3 add 2
Yeah.
to get 5, and then the minus symbols, because of the minus on the left-hand side, and then root 6 is basically 3 times 2.
What's awkward about the right-hand side?
It's got 2 square roots on it.
Yeah.
So you can square it and then get just 1 square root.
Oh.
As soon as someone said to square both sides, it all just fell into place, really, and from there on it was really simple to go through them all.
When it was pointed out that you were almost treating it as a quadratic without the x, then it almost just sort of clicks and then you can solve it.
And that immediately moved others on further. Then there was the 2 different ways of solving the final, more complicated problem in the surd.
I'm not sure if it would work, but could you do 7 plus 2 root 10?
It's a possibility.
2 root 90.
2 root 90. So you've moved the 3 inside and squared it. And have you got 2 numbers that multiply to give you, what was it, 90 you said?
Yeah, 90.
And add to give you 21.
Yeah.
I feel like if I would have just seen the second section part of the questions, when it just says find better ways to write this, I would have been a bit lost because it doesn't like put it in the form root A minus root B, or it sort of opens your own like sort of interpretation in a way.
Being able to quickly break down and have the confidence to say, well, what can I do with this? How can I get rid of this awkward square root sign? Oh, I'll just square it out of the way. I can do that. And then they can move on from there. And so even though it looks peculiar, there are bits of the problem definition that they could attack, try something and see whether it worked or not. So the next question is this one here, in terms of getting one problem done and then moving on to a second that, having achieved success, they then had more confidence. And the difference in sort of initial attitude to when they moved on to the second problem, they said, well, you could see it in the, I can take this on and I'll give it a good go.
It looks a lot more complicated than it actually is. Once you're like eased into it and you could see the general how you're supposed to think to solve the questions, just sort of like clicks in, and then you can just go through and solve all these complex questions which you didn't understand beforehand.
Using the information that you've got in the first 2, can you help that do the third one?
Would they all just be 1 squared, all the values? Because if it's offset by 1 in the second one, then technically you're minusing 1 off the offset, if that makes sense. So it wouldn't be any negative values, it'd just be taking away the value before it. So obviously the value before 1 is 0 and the value before 2 is 1, so it would equal 1.
It just helps you to answer questions in a new way. If you do a lot of problem solving, I think you can apply other methods to it, and then eventually you'll probably get it. So I think it is beneficial to do them.
We were able to lead them through lots of small problems, but they were relatively easily achievable with the scaffolding that we've been put in place as far as the problems are concerned. It gets a little bit harder in the last one, where we're not starting at 1. In terms of the final question, looked incredibly hard if you were throwing that first out, but they were all onto it. They had all got it so very, very quickly. I was very pleased with that one.
Isn't it just simply m minus 1 squared, and then you minus that from n squared? So it's n squared, open brackets, m minus 1, close brackets, squared.
I will end up using those sorts of short problems in my teaching even today. They'd fit into a normal lesson really easily. All of those problems that we've done today are accessible to all abilities. You might be able to tailor some of the problems to be more suitable to different class sets. You still end up needing to be able to solve problems. Each student needs to be able to take that one little extra step further up by being able to tackle something that they don't recognise immediately. If we end up not trying to expose problem-solving techniques, then some will cope and others won't realise that they're going to need to develop those skills. So developing those skills by making them more visible is going to help all the students rather than maybe just allow some of the students to get through.